You ever get that feeling that the universe is whispering a secret? Some kind of hidden rule that connects the smallest moments to the biggest events in a way that we can just barely feel. Well, today, we're going to pull back that curtain on one of the most amazing and poetic ideas in all of science, the butterfly effect. It's a question we've all thought about, right? Can one single tiny decision, something that feels totally insignificant, actually ripple outwards and change the entire future? I know it sounds like something out of a sci-fi movie, but it's a question that mathematicians have been wrestling with for over 100 years. And this question from the brilliant mathematician Henri Poincaré just gets right to the heart of the whole mystery. He noticed that sometimes a tiny little nudge to a system doesn't just cause a tiny little change. No, it can cause a massive, totally unpredictable one. It creates a result that looks completely random. And that question just sort of hung in the air for decades, setting the stage for an accidental discovery that would finally give us a jaw-dropping answer. So our story doesn't begin in some fancy philosophy lecture. It starts in a meteorology lab with a clunky, old, room-sized computer and a scientist who is about to accidentally stumble upon a fundamental truth about how our universe actually works. Okay, so meet Edward Lorenz. Back in the 1960s, his goal was pretty straightforward. He wanted to use these new things called computers to predict the weather. So he built this program that modeled the atmosphere, and he was hoping to find patterns that would make long-range forecasting, actually possible. So one day, he's trying to save a little time, and he takes this little shortcut that would, no joke, change science forever. To restart a simulation from the middle, he just typed in a number from an old printout. But he rounded it off. He typed in 0.506 instead of the full number, 0.506127. I mean, look at that. It's a microscopic change, less than 0.1%. That shouldn't matter, right? Oh, but it mattered. Big time. That tiny, tiny change didn't just tweak the results. It sent the entire weather simulation spiraling off into a completely different reality. The two simulations, they started out almost identical, but then they just diverged wildly, ending up with totally different weather. A single tiny cause had produced a gigantic effect. Now here's the really crucial part. Lorenz realized this wasn't just some computer glitch. He had stumbled onto something deep. The result wasn't just random noise. Hidden inside all of this unpredictable behavior, there was a clue, a beautiful, haunting pattern. So to figure out what was going on, he did what any good scientist would do. He plotted the data. He was probably expecting to see a meaningless jumble of dots, right? Just pure randomness. But what started to emerge on his screen was something else entirely. Hidden inside the chaos was this elegant and mysterious shape. And this is what he saw. It's known today as the Lorenz attractor, and it's basically the shape of chaos itself. What you're looking at is a visual map of a system that is fundamentally unpredictable, yet at the exact same time, beautifully ordered. Its path never repeats, but it never escapes its own boundaries. And yet, to Lorenz, it looked a lot like a pair of butterfly wings. Let's just break down what makes this thing so incredible. So the path the data takes, right, it never ever crosses or repeats itself. That means the system never returns to the same state twice, ever. And yet, the entire path stays confined within these two loops. But here's the real kicker. Where you end up on that path is extremely sensitive to where you begin. This is the very definition of deterministic chaos, a system that follows fixed rules, but whose long-term behavior is impossible to predict perfectly. Not just difficult, I mean literally impossible. So this mind-bending discovery, born from a simple rounding error and visualized in this beautiful shape, it needed a name, and the one Lorenz came up with would capture the imagination of scientists and all of us for decades to come. He called it the butterfly effect. The idea is simple, but it's so profound. You've heard the famous saying, the flap of a butterfly's wings in Brazil could set off a tornado in Texas. It's just this really poetic way of describing that extreme sensitivity to how things start. And of course, that name wasn't just some random metaphor he pulled out of thin air. It was a direct nod to the shape that his data had traced out on the screen, that elegant two-winged form of the Lorenz attractor. The mathematics and the metaphor were just beautifully intertwined. So, what does this all mean? Why should we care about this beyond just trying to forecast the weather? Because what Lorenz discovered wasn't just some weird quirk in his computer program. He had uncovered a fundamental truth about the universe itself. The butterfly effect isn't limited to the atmosphere, not even close. It applies to almost every complex system you can think of. The stock market, the orbits of planets, the dripping of a faucet, the rhythms of a human heart, the delicate balance of an ecosystem. All of them are sensitive, they're chaotic, and in the long run, they're ultimately unpredictable. And this discovery didn't end the story. It actually kicked off a whole new chapter. Right now, today, mathematicians and scientists are still out there exploring the frontiers of this chaotic world, developing new tools and ideas to help us navigate a universe that is way less predictable, but honestly, way more interesting than we ever could have imagined. Which, brings us right back to where we started. In a world that's governed by these deep, chaotic connections, where the smallest cause can create the largest effect, what does that say about our own lives? It leaves us with this final, amazing question to think about. How much power truly lies within a single moment, a single choice, a single flap of wings?